In this video, I will go over the general process I go through in creating pictures of astronomical objects like nebulas and galaxies. There are three phases to this process. The first is planning, which includes finding good targets, how to frame the area, and also weather considerations. The second is acquisition, that's using the telescope to take the images. And third, processing the images on the computer to get the final result. To start off, I first use an open source planetarium application called Stellarium. I use it to find interesting things in the sky from my location at the current time of year. And then I also use it to experiment with the composition of the scene by trying different camera angles. Finally, I look at the weather forecast to see if there are any upcoming clear nights with no clouds and no chance of rain. Next up is taking the photos. This starts by assembling the telescope outside and roughly pointing it north. This is done a few hours early so all the optics can reach equilibrium with the outside temperature. After it gets dark, the telescope is focused so the stars are sharp. The telescope then has to be aligned with the north celestial pole so that the long image exposures can be done without the stars rotating, causing them to blur. After polar alignment, the telescope is pointed toward the celestial target and the camera is rotated to get the desired photographic composition. A light panel, with controls and a custom adapter that I 3D printed, is placed over the telescope and a series of photos are taken called flat frames. These are used to correct for any dust spots or vignetting, which is when the edges are darker than the center of the image. Next is setting up the star guiding. While the computer-controlled mount is quite accurate, it still has pointing errors. So a secondary camera sensor is used to track along with the stars to ensure the pointing error is less than an arc second. Finally, the photo plan is entered into the telescope controller to take a large number of images throughout the night. The exposure length depends on a lot of factors such as brightness of the object, filters used, and how much light pollution there is, but are typically between 1 to 5 minutes long. Since deep space objects are very dim, photos of the same target are taken over a few nights to collect enough light. The processing phase has two main steps. The first is called stacking. It is the process of combining all the individual frames, or subframes, into a single master image. This process combines the light from all the images and also helps to average out the noise. So the more sub-exposures, the better the result. I use a specialized astrophotography application called PixInsight to do this. This step is quite computationally intensive. For a few hundred images, this can take a fast computer a couple of hours and requires a lot of computer memory and storage space. After the stacking is complete, we are ready to start the last, but often most complex part, the enhancement of the image. This is done using the PixInsight application again. This process is primarily done manually and is equal parts art and science. When you first open the master image, which is the combination of many hours of light gathering, they typically look like this. The image is almost all black. These objects are that faint. But there is a lot of information in this photo, we just have to extract it from the shadows. This is the part I found the most surprising, as I thought after 20 hours or more, the image would look a lot more impressive at this state. To start the enhancement process, I temporarily boost the data out of the shadows to see what is there. This initial step doesn't actually change the data in the photo, it is just done to get an idea of what corrections are needed next. The first correction that is usually needed is to fix the color balance. This is done through a process called spectrophotometric color calibration, or SPCC. Next, a tool called Blur Exterminator is used, which is an AI-based deconvolution algorithm that can partially fix optical issues like being slightly out of focus. Now for a fun part. All the stars are removed. This is done so I can separately work on the stars, which are very bright, and the background, which is faint and colorful. On the starless image, gradients, such as light from the moon or light pollution, are removed, and then some of the background noise is reduced using another AI-based algorithm. At this point, the images are ready to be stretched, which is the process where the details are permanently pulled from the shadows and spread over the entire brightness levels of the image. Next, I usually export the starless image and open it in a more standard photo editing piece of software called Affinity Photo to adjust colors and enhance the image's contrast. In Affinity Photo, multiple layers of color curves and selective color enhancements are made. Once everything looks good, I save and then import the image back into PixInsight. Finally, the stars are recombined with the background and the image is complete.